Welcome to a podcast on the rectangle. So a rectangle is a parallelogram with 4 right angles. That's its official definition. It is a special kind of parallelogram because in addition to the features of a parallelogram, it has its own requirements. Okay, so because a rectangle is a parallelogram, it has all the properties of a parallelogram. Its opposite sides are congruent, its opposite sides are parallel, its opposite angles are congruent, its consecutive angles are supplementary, and the diagonals bisect each other. But in addition to that set, it has 2 other features that apply only to the rectangle. So applying to the rectangle are that all angles are congruent, they're all right angles, and all the diagonals are congruent, or both diagonals, there's only 2. All right, so because let's see if it wants to write. There we sort of go. All right, so something happened there. So because our angles are congruent, we'll get it. There we go. Once it writes the first time, it's always good. So because the angles are congruent, the diagonals are congruent as well. All right. So let's take a longer look at the rectangle. So you have this in your notes. Right? So the rectangle has all of the properties of the parallelogram, and if you ever forget those, you could always review your notes on parallelograms, plus 4 right angles and diagonals that are congruent. In your notes, you have a rectangle, and you're going to mark all of the features. All right, so you're going to mark that the angles are parallel. Right? The sides are parallel. The opposite sides are parallel. Notice I have that written in blue on my notes here. So AB is parallel to CD, and AD is parallel to BC. You're going to mark that the opposite sides are congruent. Right, and I have that written in green. AB is congruent to CD. AD, that's a D. AD is congruent to BC. You're also going to write down that all the angles are congruent. So the opposite angles are congruent, but in this case, since they're all 90 degrees, so are the consecutive angles. Although technically, the consecutive angles are supplementary. But all of our, because 90 plus 90 is 180, but all of our angles do equal 90 degrees. So angle in red, I have it written down. You'll add this to your notes. Show that there's 4 right angles in your rectangle there, and write down that angle A is congruent to angle B, and is congruent to angle C, is congruent to angle D, and they all equal 90 degrees. And finally, because your diagonals are bisected and your diagonals are congruent, all 4 of those segments that make up the diagonals are the same length. They are congruent. So I have that written in black. AM is congruent to BM, is congruent to CM, is congruent to DM. So add that to your notes. There are 3 ways to prove that a quadrilateral is a rectangle. All right, first of all, if a quadrilateral has, and you add this to your notes, 4 right angles. You have to prove 4 right angles. Here I have the right trapezoid. All right, so this is why you have to prove that a quadrilateral has 4 right angles to prove a figure is a rectangle. Because here you notice that my right trapezoid has 2 right angles, but then the other 2 angles are not right angles. Right? So in a trapezoid, these angles and the angles on the other side over here, I'll put a little arrow, those are always supplementary. So our right angles always occur in pairs with the trapezoid. And of course the trapezoid is not a kind of parallelogram. It only has 1 pair of parallel sides. All right? So that's one way if you prove a quadrilateral has 4 right angles. Or if you prove a if a parallelogram has 1 right angle. Any old quadrilateral has 4 right angles, and that proves it's a rectangle. Or if you prove that the figure is a parallelogram first, you only have to prove it has 1 right angle. Because if it's a parallelogram, we know the opposite angles have to be congruent. So there's two right angles. And the consecutive angles have to be supplementary. And so 180 minus 90 would give you 90. And there you go. There's your four right angles. Or you can prove a parallelogram has diagonals that are congruent. All right, so both method 2 and 3 above there require you prove the figure is a parallelogram first. There we go. Taking my writing a little while to come up. At some point the word first will probably come up. There it comes. All right, so the first method doesn't because you're proving the right angle, all right angles. And in essence, if you prove that the figure has four right angles, you end up proving it's a parallelogram. To be a rectangle, you have to be a parallelogram. I can't go to the box. All right, so now let's take a look at, so make sure you add this to your notes, right? And then let's take a look at solving with rectangles. There, I got the box again. Solving with rectangles. I just can't win. There we go. All right, so we're going to, and this is in your notes as well. All right, so you have that diagram and you have these questions. So if AE, so AE would be this one. If that is 3x plus 2, and BE, I'll use a new color, I'll use purple. BE here is, or red. That's good enough. BE is 29. Find the value of x. All right, so remember on the previous page, we showed that, we talked about how the diagonals are congruent. And we know in a parallelogram, the diagonals are bisected. So that means that all of these are congruent, right? Not just the ones on the same diagonal. Since the diagonals are congruent, all of those are congruent, right? So in other words, AE is congruent to EB is congruent to EC is congruent to ED. All right, so, oops, not DD, ED. So we'll just set 3x plus 2 equal to 29. Oops, I wrote it in the wrong spot. And we'll have the answer to this question. I'm just going to move this up. There we go. All right, and then let's solve. So it's easy as 3x plus 2 equals 29. And we subtract 2 from both sides. 3x equals 27, which means that x is equal to 9. Okay. Let's look at the next one. So the measure of angle 1 is 4x. Okay. And the measure of angle 4 is 2x. Find the value of x. Well, notice there we have a triangle. Right? And so this angle is 4x, and this angle is 2x. But this isn't just any old kind of triangle. Notice the congruence markings there from the diagonals. So these two sides are congruent, which means this side here has to be 4x as well. So to solve here, oh, it looks like I skipped a question. That's all right. I'll go back and answer it. All right, so to solve this one, we would simply add up the angles in a triangle and set them equal to 180. We use triangle sum theorem. So we have an isosceles triangle, and then we're using triangle sum theorem. All right, so 4x plus 2x plus 4x equals 180, which means that 10x equals 180. And if we divide both sides by 10, x is equal to 18. All right, now let's solve the question I keep skipping. And I'm going to probably erase some of this so that we can see. Maybe. There it goes. All right, so we have this time I want purple. There we go. I'm running out of colors. This time AC, that looks like black to me. And maybe it just doesn't like to change colors when I record. All right, so AC there is equal to 21. We want to find the measure of BE. And so BE is this part right here. All right, just that part right there. All right, well, we know, like we said in the problem number 1 there, all of these are congruent. All right, so BE is just going to be half of AC, which means that BE is half of 21, which would be 10.5. There we go. Actually, I'll put it up here. 10.5. All right, and so now we're done with this one. Go away. All right, let's do the last one, and we're going to find the measures of all of the angles. All right, so again, I'm going to erase this so we have places to write. All right, so we want to find, we're given that angle 2 is 40 degrees. We want to find the measure of angle 1, angle 3, angle 4, angle 5, and angle 6. And this is actually really, really easy. All right, well, first of all, angle 1 plus angle 2, that equals 90 degrees, right? So since angle 1 plus angle 2 is 90 degrees and angle 2 is 40 degrees, angle 1 must be 50 degrees. So that was just 90 minus 40. All right, angle 3, well, this is, remember, these are all congruent. So that means that's an isosceles triangle, which means angle 3 is the same measure as angle 2. These are congruent right here. So that would be 40 degrees. All right, so now let's find angle 4. All right, and actually I'm going to find angle, actually, no, we'll find angle 4 because I forgot to write this in. This was 50 degrees. All right, well, that's an isosceles triangle as well. That means this is 50 degrees. And how many degrees are there in a triangle? Well, we know it's 180. So angle 4 has to be 80 degrees. So it's just 180 minus the two angles that we have up there, minus 100. Okay, now angle 5, oh, let's write this in. This is 80 degrees. All right, well, those are a linear pair. So angle 5 has to be 100 degrees. Right, they are a linear pair. And the last one is angle 6. All right, these two angles are congruent. Right, so there are 80 degrees for them to share. Angle 6 is 40 degrees, the same as angle 2. Right, and that would just be the fact that that's an isosceles triangle and using triangle sum theorem. All right, so there we go. We've solved all these out. I will come back in the next podcast. We're going to do a little bit more with rectangles, and maybe I'll introduce you to the rhombus. All right, bye for now.